Our next speaker is Dr. Ko Su from ULBAC. He is currently the General Manager of ULBAC's Institute of Semiconductor and Electronics Technologies. He will be speaking about the development of LED manufacturing equipment solution. His expertise involves technological development for LCD and LED-related mass production. 下一位讲者为优贝克半导体技术研究所所长 Dr. Ko Su， 讲题为 LED 制造装置技术之进展。苏博士拥有多项 MOCVD 以及 LED 相关量产技术开发经验。Let's welcome Dr. Ko Su.
The title of my talk is the development of LED manufacturing equipment solution. There's three parts. In background, I will give the review again the requirements from the LED chip manufacturing, and I will talk about our solution, process solution for the chip manufacturing, including mentioning several recent development topics, and then I will talk about the future perspectives, and I will summarize. Background. So the past year, there's something not yet changed, which is we still see the energy consumption worldwide keep increasing, and we see these requirements to suppress the greenhouse effect. This demand is getting stronger, and so that's why this for the years people is busy to trying to work out a solution to obtain the natural energy, or say green energy. But we do have something get changed. So if you look at here, Dr. Xie from LP this morning, this morning mentioned we had a huge disaster this year in Japan, the nuclear accident. But if you look at the composition of the energy, actually, if you compare with the others, the nuclear energy actually is a kind of a green energy, and it's actually participates in a very large volume part. And actually, the red, this part actually is so-called solar energy, or say new renewable energy. Apparently, this one cannot really replace the others, and so now we're missing the nuclear, and so all of a sudden that's why there's huge surge of the LED lighting markets in Japan, because people now understand that we cannot really increase the energy harvesting, and we have to save the energy. So that's why I guess in the LED in Japan the market is very good. Especially the lighting, and so I guess I'm trying to say that LEDs, certainly at least in Japan, will keep to be the champion of the energy saving. Give us enough reason to work on this technology. So the applications, as I mentioned, we have solid state lighting. So it's displays, automotives, a lot of things here, and we know to come up with a good technology, we need to put all of the things together, from material, equipment, process, and the chip integration until the packaging and process. The markets. I think the previous speakers has talked about much newer information. We still see rapid growth, we hope, although we do see some difficulties for the recent for this year. Again, what is required, I think, fundamentally still we want to get better efficiency and the lower costs at the same time. So one thing people are looking at, I guess, is to make the LED light size. Well, for the better performance, this morning there's a lot of previous speakers talk about how to obtain a good, better IG and EQE. So from our standpoint of view, I put some items here, which these items will also lead to requirements to processing the equipment. Like the PSS formation, and we need a better ITO with a smoother surface, and we need good light reflectors or transmitters. So we're trying to do something like the multi-layer dielectric films, and the heat sinking will also be a challenge. So I'm going to also talk about some trials for us on this part and damage control. Well, certainly we want to improve the productivity, including both the throughputs and also the yield. We do also put some items here, and the cost. Well, everything is connected to each other, but basically we want to reduce the equipment cost and the process costs, including the material cost here. Okay, now I'm talking about the several topics from our developments. Well, this is the flow of the chip making of LED, and so actually this year we add we call it the packaging part, which is we're trying to utilize the TSV through silicon via technology to hope to help improve the heat sink. What's all that we're working on most technologies except the CVD. I remember last year I mentioned we were probably going to look at this technology because without this technology we were being facing difficulties to even evaluate the other technologies when we try to look at some solution development. So one motivation for all that is to utilize, to have this technology and for helping the other technology developments, and hopefully can be a year ago we were facing a very long lead time in markets, and hopefully our can be a supplement of this to the major suppliers. So that's the second motivation. So we do work on this technology now. Hopefully we can release it soon. Other than that, we're pretty much working on everything. And look at the trend of the chip process. I think one is to get hybrid, vertical LED. In that case, there's everything, including the increasing the light extraction area by doing the substrate lift off and or roughing the surface, or also improve the light reflection by utilizing the multi-layer dielectric film. And as I mentioned, to improve the heat sinking, to utilize this TSV copper-filled TSV the silicon submounted substrate. And another thing is that to make the ITO flow smoother. Also, try to make this PSS and sometimes incorporate with the air gap to increase the extraction efficiency. So several topics. So for etching, we use etching to make the PSS and also to form the to do the galvanized etch. So one thing we're doing is that we adopted a new tray with electric static shock to improve the performance. And the size of the tray now we're testing a quite large one, which is 450 millimeter trays. In that case, we can have 55 pieces, 2-inch substrate. These are some examples. Work on the PSS we were making, and by utilizing this tray, we can improve the throughput, both the throughput and the uniformity, pretty much. Because we can have now we have a very good cooling of the substrate, and we can do the replacement of the D-check altitude, so to improve the throughput. Another trial for us is trying to implement a sputtering buffer layer, hopefully replacing the current CVD buffer layer. So certainly it's been very difficult for the quantum world, but our hope is that to this buffer layer and hopefully undoped or up to this place, if we can use the sputter, which is low cost and high throughput process, we can do that. It's going to be beneficial for the whole throughput. So gallium nitrides or the film, if we can use sputter, certainly it's going to be carbon free, and we found it can also have very good crispinity. For nitride buffer, we have been confirming the uniform grain growth and smooth surface morphology and good epi crispinity. This is example of the 8-inch uniformity. We can pretty much achieve the thickness uniformity less than 1.5%. This is a 200 millimeter in diameter. And this is the data on for the evaluation of the nitride 002 is on the 6-inch sapphire. We see the uniformity of the intensity is pretty good. It's around like 2%. And the whole figure also shows it's the textual growth is typical happen very well. And we'll put MLCVD galvanizer on top of it, and then we'll see this it's very smooth and small surface roughness. And comparing with the CVD gallium nitride buffer layer. We even find the crystallinity is somehow better than the conventional ones. So this is the data shows that how thick the nitride required. So this like 10 nanometer, we can pretty much achieve a very nice crystallinity. And based on our calculation, we can, for that part, we can pretty much reduce the CO by 8%. And the data show that LED chip in fabricate with this technology shows higher yields at around 10% luminescence intensity. I have only one page show the progress for the gallium nitride on CVD. As I mentioned, we need somehow to make the CVD gallium nitride to actually examine our other technology. We're do something. We're trying to do something this. Again, we do have a tool now, and hopefully it can be a supplement to the other suppliers. The other item is the ITO sputtering, and people used to use the evaporation ITO. Now we found that the sputter can give us much smoother surface, which can reduce the contact resistance, and also improve the transmissivity, reducing the VF. Also the range here, so the control is also very good. Another trial is to try to implement the optical, the multi-layer optical films to use it as a light reflector. This is an example that this is tandem oxide, silicon dioxide multiple layers. And we use it to replace the conventional metal reflector, and you'll see the reflectance is higher than required, and at the range required, it shows very good control fit. So which means the process margin is much higher, much larger. Okay. And we do have another, actually this is a kind of a solution, a TSV solution. We have been developed for the other technologies, including the 3D IC or the GANs, the other technologies. So we're trying to apply that to LED. Well, the reason is that we think this might be beneficial to put the TSV with cover fields and use it as a supplement to improve the heat sink. So some examples here. So we can make a pretty nice, deep and smooth vehicle by utilizing our plasma etching technology, and the uniformity is very good, and also we do see a notch free on top of the oxide. And this is, as I mentioned, this is a solution. It's not only just the making a hole. You have to fill the cover finally and come up with the supplement. So we do have this process solution which is ready for the implementation. Okay, future perspectives and one of our trials again that we do hear a lot of things on the yield, how the currents, the laser lasers, somehow damage the yield. So we think maybe the chemical is beneficial. So we're doing some experiments on that. Well, we do identify several materials can help us to lift up the substrates efficiently. So it's we might need to do some more things to get the throughput higher. So this is ongoing. Another trial is to try to also do gallium nitride spotlight. We do see the personality. It's not bad, but we're improving in this process. One of I guess I don't see it a lot here in Taiwan, but in Japan there's a lot of discussion recently on gallium nitride on silicon. The next speaker, I guess, will talk a lot more details on this. We do feel this might be a game changer in the future. So hopefully, finally, we can come up with something to see this LED can say integrated with CMOS, which is based on the silicon technology. Then I guess there's huge possibilities in markets, possibilities. Alvec has been working also on the silicon semiconductor technology, so hope we can also serve for this technology trend. The several challenges, I guess, buffer layers is going to be most important to. So one is for the textual growth, the other is going to be to reducing, minimize the stress, and also because we're going to use silicon in the low temperature processing if necessary, including the gallium nitride in CDD. And maybe the single wafer processing, which is that like silicon semiconductor now, will be the way in the future also for manufacturing LED chip. So we want to understand this more and that you be prepared for that. Well, this page is a summary. We want, hopefully we would like to provide a new solution, a process solution, which not everything, but hopefully some part will be beneficial for the customer and for the industry. Now we're close to have our own CDD, gallium nitride CDD technology, and hopefully this will enhance our the process solutions in the future. Thank you.